welcome to our meetup about Node Streams. Gadi, sorry for, how do you pronounce it?
Gadi. Yeah.
Gadi.
Yeah.
Gadi is gonna be our presenter today, and he's gonna show us the insights of Node Streams. And as I said a little bit earlier, I'm really excited that we have a Node talk. And Gadi, do you want to say a few words about you before you start?
Yeah, I'm really excited to be here, to have this talk in this meetup. I'll present myself in the talk.
Okay. So you can start when you're ready.
All right. So this is taking Node.js to the extreme. My name is Gadi Raymond. Let me minimize it. All right. So a little bit about myself. I'm from Israel. I'm married to Hila. We have a son named Ori, and a dog named Angie, as you can see in those pictures. I'm a senior full stack developer at a company called WalkMe. I love to speak and write about technology, just like I'm doing here today. And feel free to follow me on Twitter. It's Gadi Ray, where I mainly tweet about JavaScript, Node.js, and basically everything that's exciting and new in development. So what we're going to cover in the next 30 plus minutes, I will show you my big data challenge that I had in WalkMe. Then I'm gonna do a quick introduction about Node.js Streams, and then I'm gonna show you how I was able to solve the challenge that I had using Streams. Then I'm going to go over some tips of using Streams, and then we're gonna dive into some more advanced stuff like async iterators and async generators and how they are related to streams. So let's start with a little story. So when I had the challenge in WalkMe, and one of the solutions to the challenge was using streams, I had to admit that I was a bit afraid of using streams because streams have a bad reputation. People are saying the streams are hard to learn, how to work with streams. People are afraid of using streams in production. And I think the main reason for it is that streams are available to Node since the first version of Node. And back then, the API wasn't really baked like it is today. So I think people are still remembering it. And even in the social media, you can find tweets like this for all of you React lovers. This is Dan Abramov, the creator of Redux. He's saying that he's afraid of streams, right? So when I started working with streams and reading about streams, I saw that streams are not that hard. And actually the API since Node 10 is really nice. And my goal in this talk that your next tweet will be this, to love streams. So in order to explain you the challenge that I had, I need to do some sort of overview of our architecture. So in WalkMe, we have a web application that shows all sorts of data and analytics about our user usage of WalkMe. And users can choose to export this data in a CSV file to their email. So when a user clicks on export, we send a request and send it to a reports queue. And those messages have a generated SQL query that we are generating according to the user filters and preferences. And we have the consumers. Those consumers, you can see there is more than one consumer that subscribe to this queue. And those consumers are Node.js apps. And their job is to take those messages, take the SQL query, and query our DB, which is called Athena. Athena is a managed service in AWS. It basically wraps analytical DB called Presto. Presto is developed by Facebook. And what Athena does, it takes the result sets of Presto and save the result sets to a CSV file, save it to S3, and return the URL of S3, and then return it to our consumers. So now our consumer can take this file and send an email to the user that asks to export the report. So this is basically the feature that we had, and everything works well in production until we started to grow more and more. Started to have more and more users using this feature. So we started to have more and more messages in this queue. And we didn't have problem scaling those consumers in order to cope with those messages. But we started to have a bottleneck in this area, in the Athena area. The reason for the bottleneck is because, as I said, Athena is a managed service. It has some limitations. The first limitation is that it only supports 5 concurrent SQL queries. And in our case, since it's analytical DB, queries can take long. It can take a few minutes. In our worst case, it can take even 30 minutes. So we started to have a bottleneck here. And another limitation of Athena is that the compute power is fixed. You can't change it. And as I said, we grew more and more, started to have more and more data. And we simply needed more compute power to handle complex queries. So in order to solve it, we decided to manage a Presto cluster on our own now. So now we don't have the limitation of the 5 concurrent queries. And we can just scale in and scale out nodes in the cluster. And we don't have the limitation of the compute power. We can just increase the machine compute power if we want. And so now the flow goes like this. The consumers takes the same SQL queries, but now they are querying the Presto DB. And the Presto DB returns the data as JSON. So now it's on the consumer's responsibility to transform the data from JSON to CSV files, save it in S3, get back the S3 URL, and send an email just like we used to do before. And this is basically the challenge that we needed to implement. And this is what I'm going to talk about here now. So this is a naive solution to it. This is an in-memory solution. And when we get the SQL query here, we have a function called export events. And get all events will return those events from our DB, from our Presto DB, as JSON, as I said before. And so we need to convert them from JSON to CSV, right? So we have JSON to CSV function here. As you can see here, this is a synchronous operation. And it's really, really not recommended to do those things in Node.js simply because it can block your event loop. And in case you block your event loop, you can't really receive any request. And you really want to avoid those kind of things. So once we get a CSV format, we can write this file, in our case, to S3, write this CSV file. So let's see this code in action. I will do a quick demo. So this is the code that I showed you. And wait a second. So I'm not really calling here a DB. I will simulate the result sets from a DB by reading from a file. So I'm calling this function, the export event in memory. And this file is small file.json. It's at 8 megabytes of JSON. And after it, I'll print the memory usage of this program. So let me run it really quick. And it took 83 megabytes of memory. And this is quite a lot, right? Because I told you that small file.json is 8 megabytes. So what will happen if I'll change it to big file.json, which is 400 megabytes of JSON. So as you can see, it takes time. I'm using Node 14, which is the latest version of Node. And in Node 14, the default memory size is 2 gigabytes. So let's wait a few seconds in order to process it, and let's see what will happen. All right, we got an error, as you can see here, V8, which is the engine of Node.js, and a very long stack trace, and its fatal error says JavaScript heap out of memory. So we exceeded the 2 gigabytes of memory in this case. So I don't know if you know, but there's a flag that's called the max odd space size that can increase our memory from the default 2 gigabytes to, in this case, 4 gigabytes. So I can use it. And let's see what will happen now. Yeah, I was able to process this data. It took me 2.6 gigabytes of memory. But there's a problem with this solution, right? Because this solution doesn't really scale. As our data will be bigger and bigger, we have to increase our memory each time. And if you're working with microservices architecture, you want your services to be as slim as possible. And also you want to avoid this line that I told you before. You don't want to avoid doing CPU intensive stuff. And as your data will get bigger and bigger, this function will take more and more time to process, and you simply will block your event loop. So we really want to avoid those kind of things. So let's get back to the presentation. And before I show you the solution using streams, let's do a quick introduction. What are streams? So streams are interfaces for reading and writing data. And streams can be piped together. Just like Linux command, when you got the first command, the pipe, and the second command, and the output of the first command will be passed to the input of the second command, streams work the same. Streams are piped together to each other, and they pass chunks of data. Node.js Streams extends event emitter, which means that our streams emitting and subscribing to events in order to communicate with each other. So in order to pass chunks of data between streams, streams will emit and subscribe to the data event. There are all kind of events. There are a finish event, close event, error event, etc. And there are all sorts of stream types. So there are 4 stream types. The first type is readable stream. Readable stream will always be the first stream in the pipeline. Is responsible from reading data from a source. It could be a DB, it could be a file, it could be stdin. And there's also writable stream. Writable stream will always be the last stream in the pipeline, and is responsible for writing the data to, again, all sort of sources. It could be file, it could be DB. And duplex stream is readable and writable, but the readable and the writable are independent with each other. So a good example to duplex is HTTP sockets, when you can read from socket and write from socket independently. And last is transform stream. Transform stream extends duplex, which means that it is readable and writable. But this time, the readable and the writable are, the read and the write are dependent with each other. So that means that transform stream can read data, transform it, change it, and write the same data forward in the pipeline. And this is the solution to the challenge using streams. So I'm getting, this is the same SQL query. I'm wrapping it with promise because I want to still work with promises. And so now read all events will return a readable stream. JSON to CSV will return transform stream, and write all events will return a writable stream. So after these 3 lines, all I'm doing is initializing a streams object. Nothing is done here. Only when I'm piping them together, only then it will signal the readable stream to start read data and start move data in the pipeline, chunks of data in the pipeline. So since I'm working with promises, I want to resolve the promise once the pipeline is done. So I'm subscribing to the finish event on the last stream in the pipeline, the write stream, and then I can resolve the promise. So this is the 2 solutions. Now let's compare them. This is a bit spoiler, I know, but you can probably guess the results. So I have stream.js, which is the code that I show you now. And let's run it. And I'm doing the same trick here as I did before, not really calling a DB, but I'm reading from a file, which is bigfile.json, which is 400 megabytes of JSON, and then printing the memory again. So let's wait a few seconds here and see how much memory this time we used. Yeah, we used 22 megabytes, only 22 megabytes, which is far less than the 2.6 gigabytes, right? And what's more impressive about it is that this solution can scale, right? Here I used 400 megabytes of data. In WalkMe, we can get to gigabytes and tens of gigabytes of data, and the memory usage will still be the same. You can even work with terabytes of data, and you can the memory usage will be like this. So I have to admit, it really surprised me that a single node process and streams can handle this kind of big data. I always thought that in order to cope with big data, you need some sort of big data solutions like Hadoop, Spark, and clusters and things like that. But it turns out that Node.js and Stream can really do the job for you if you need to process really big data with small memory usage. So let's get back to the presentation. And now that you saw that streams are awesome, you probably ask yourself, can we create a stream by our own? And like that man said, yes, you can. And this is an example of readable stream, of a custom readable stream. And this is the syntax since Node 10. So you see I'm requiring from stream model, which is built in Node.js. I have to do new readable here and implement a read method. And this read method has a size parameter. Here I'm not using the size parameter. The size parameter is the size that you're going to read in each chunk. And I'm not using this parameter because here in this example, I'm generating the data on my own. This is hello JSHeroes string. I'm using the spread operator here and changing it to array of characters and iterating over each character and doing this dot push to the character. So it will write this data to the next stream in the pipeline. When I'm done iterating over this string, I'm doing this dot push with null, and this will signal the next stream in the pipeline that I'm done reading the data. And this is an example of transform stream. Again, requiring from the stream model, doing new transform here, and then I have to implement transform method. And transform method get chunk, which is the data from the previous string, encoding and callback. We will call callback once we are done transforming the data and we want to write it forward in the pipeline. And the first parameter is an error. So I'm passing here null. And the second parameter is the data that we want to transfer. So I'm doing chunk.toString because chunk is buffer type, and doing to uppercase because this is the transformation that I want to do. And if you pipe everything together, the readable stream that we did and the transform stream that we did, we pipe it to the process std out, which is a built-in writable stream in Node. We will get hello JSHeroes, all capital letters. And this is really basic example, but it's just to demonstrate you how easy it is to work with your own streams and piping them together. Let's talk about tips of using streams. The first tip that I have is based on a real-life example, error handling. So I had this code in production, and this code can break, right? Because we are reading data from the DB, we're transforming the data, we are writing to S3, we're doing all sorts of things that can break in the way. So I did what every developer will do in this scenario. I will wrap it with try and catch, right, in order to catch those errors. But it turns out that this is not enough when you're using streams, and basically we got unhandled promise rejections in production. So in order to solve it, what you need to do is subscribe to an error event in each stream. So if an error will occur in a stream, it will trigger the error event, and then you can reject the promise. And you won't get unhandled promise rejections that way. But there's a duplication of code here, right? Because you have to do the on error on each stream. And you can improve it by, instead of working with the pipe method, you can work with the pipeline API, which is built in the module stream. And pipeline API gets as parameters the streams and connect them to a pipeline. And what's really cool about the pipeline API is that it has a callback. So if I have an error, no matter where in those streams, it will call the callback with an error, and then I can reject the promise. So it removes the duplication of the on error on each stream. Another cool thing is that the callback, if the pipeline is done successfully, the callback will be triggered also with no error, and then I can resolve the promise. So I can even remove the on finish that I had before. And if you want to improve this code even more, if you want to improve this code even more, you can use util promisify, which is also built in Node.js. And it will change pipeline from working with callbacks to working with promises. That way pipeline async will return promise. And then you can just await on the pipeline API and the pipeline async. Then you can try it with, wrap it with the try and catch, and then you can catch those errors. Another important thing in streams is back pressure. So back pressure is a scenario when you have two streams that are connected to each other, and one stream produces more data than the other stream can handle. And this can cause back pressure, and back pressure can cause you to use a large amount of memory, and you can have the JavaScript heap out of memory, just like I showed you before. So we really want to avoid it. And don't do this. Don't subscribe to the data event and write from this data event to the next stream in the pipeline. It can potentially cause you back pressure problems. What you need to do is work with the pipe and the pipeline API that I showed you before. And luckily for us, the core team of Node took care of back pressure balancing in those APIs. So you just need to call them and you'll be good. Another useful thing is object mode option. The default object mode option is an option that you can pass to streams. The default value of object mode is false. And when it's false, you can read and write for streams only strings and buffer types. So if you're working with objects, like in this example, you need to stringify the object here, then push it. And in the transform stream, you need to parse it, transform it, and then stringify it back. So it's much more easier to work with object mode, and then you can push objects to streams. In the transform stream, you have readable object mode and writable object mode. And then you can just transform it and move it as an object. And it's really useful and saves you all the stringify and parse. Another important option is high watermark options. High watermark option sets the size that you're going to read or write, the size of the chunk that you're going to read or write in the stream. The default value of high watermark is 16K. And you can play with this number in order to optimize things. And it's basically a trade-off between the memory size that you will use and the speed that you will be able to read or write from your stream. So let's talk about generator functions now. Generator function is not something new in Node. Generator function creates iterable objects. And stay with me, I will explain it in a second. This is an example of generator function. So you can see it's a function with an asterisk, and we have a yield keyword here. So generate sequence takes start and end indexes, and iterating over with for loop from the start to the end and yielding each index. So this is the usage of generator function. So if I call generate sequence with 1 and 3, it will return the generate object, which is an iterable object, which means that is implementing the iterable protocol. And iterable protocol means that this object has a next function, and this next function return an object that has a value property. And if you call next each time, it will generate the next sequence. So if I'm calling next with value for the first time, it prints 1, then prints 2, and then prints 3. But there's more elegant use to generators, and you can do for off loop over them. And if you do for off loop over generate object, then you don't have to call the next and the value. Node will do it for you, and then you can print 1, 2, 3. But why I'm talking about generator functions and how they are related to streams, the answer to it is that you can create readable streams from generator functions. So take a look over this example. This is the example that I showed you of creating readable streams with hello JSHeroes stream. And this is an example of generator function that takes those characters and yielding each character. So if I'm taking the readable from a stream module, I can call readable from with a generator object. Here I'm calling the generate function. And it will create a readable string from this generate function. You can see I can pipe it to the std out, which is the writable string. And this syntax is much more easier and much more useful than implementing this read and doing this dot push and this dot push now. This is much more easier, much more elegant. And this is just an easy example. But in my opinion, this syntax helps a lot here. Let's talk about async generator functions. So I showed you generator functions, and generator function can be async also. And that means that they are creating async iterable objects. And this is the same example of generate sequence, but this time it is async, right? You can see the async here and await. And in this example, I'm awaiting for set timeout with 1 second. So let's see usage of it. So this is generate sequence async. It will return a async iterable object. This async iterable object implements async iterable protocol, which is basically the same as iterable protocol, but this time the next method is returning a promise. That's the only difference. So if I'm calling next here, I have to await and do the dot value, and it will print 1 after 1 second. The second time, it will print 2 after 1 second, and then print 3 after 1 second. And a more elegant use to it will be for await off loop over this async iterable object. And then you will avoid doing the next and the dot value, and it will basically print 1, 2, and 3 with 1 second delay over each one. So streams can work with async iterators because all readable streams are async iterable objects by definition, which means that you can do the for or wait off loop of a readable stream. And this is again, very useful syntax. If you're working with readable streams, you can take the chunk of the data and basically do whatever you want with them. You're just showing you an example that you can do to uppercase. And what's even more cool about it is that you can work with async generators and async iterators. You can combine those two together. So this is an example of async generator function. You can see async with function asterisk with text that takes a readable stream and doing for await off loop over this stream and yielding the results and doing the to uppercase transformation. And another thing that is cool, Pipeline API supports generators, which is brand new in Node 14. This is a brand new syntax that the Pipeline API supports. So Pipeline APIs I showed you supports, before Node 14 supports only streams. But as you can see here, I'm passing it anonymous generator function. Just all it's doing is reading from the hello JSHeroes and yielding each character. And the second parameter here is anonymous async generator function that gets this stream, doing the for wait off loop, and yielding and transforming it to uppercase. The third parameter is the process std out, which is a stream. So you can combine them. It's very useful and very cool syntax. It really reminds me of Express middlewares, and when you can pipe those middlewares together, basically each middleware implements some contract. In Express is rec, res, and next. And here it's the same. Generator functions, they implement some sort of contract that supports it. So let's sum things up here. don't afraid to take Node.js to the extreme. That just like I showed you here, turns out that simple process of Node and Stream can handle really, really big data. Streams API is easy. Just like I showed you here, you can create streams by your own. The documentation of streams is very, very, very good. And just as I showed you in the last example, the core team of Node improves the API more and more. And follow the best practices and tips that I showed you here, so you can work with streams properly and you optimize your usage of streams. So this is basically it. If you have any questions, feel free.
So for questions, you can either mute yourself directly or you can write them in the channel. It's up to you. I can start until everybody thinks. I'm curious, so you said you implemented the first method that was consuming a lot of memory first, no? What other options did you explore before choosing streams, or how did you end up with streams?
Yeah, so we had two options that we explored. One option was to work with the child process and try to split this data, the process of this data to chunks, but it wasn't really effective. And since we are using child processes, if one of them will fail, it will be very hard to synchronize the results and to handle the errors. Another thing that we try to do is do some sort of pagination on the DB. And as I showed you here, we used PrestoDB, and pagination on PrestoDB is something that is really, really hard to do. If you're working with Postgres and MySQL, I think pagination is much more easier. And we had problems doing this pagination. But if you think about streams, streams are some sort of pagination because you are reading chunks of data each time. So it's kind of pagination from the DB. And you read this data and move it forward. You read another data and move it forward. So streams was the best solution that we saw. Don't be shy.
Yeah, it's usually either ways, either too many questions or nobody's saying anything.
I can ask questions to to the audience. I'm curious if someone was has experience with streams in production.
I don't.
Yeah.
Omri asked a question. Can you share some real world use cases?
Yeah. So this is a real world use case that I showed. It's really a feature that we have, but I can show a use case that you can probably more relate to it. So if you want to stream a video, I guess like Netflix and YouTube and things like that. So so you have probably a client in HTML, and you want to fetch a video, and video is a data, and video can be big. Video can be gigas of data, and you don't want to to fetch all this data at once to your client. It will be heavy and not efficient. So what you do in a video, you just ask the server each time for a chunk of data. And the server will return a stream for you. Actually, there's a HTTP status for it. It's 206. And when we return 206, the HTML knows to take it as a stream and process it each time. And then you can play your video with stream. I'm seeing another question
Yeah. You
in
want
the
me to
chat.
repeat it, or you'll do it?
I can read it. Okay. So didn't you have to stream the data from the DB as well? I assume the stream solutions work if the data source is also sometimes a stream form. Yeah, this is something that's important because I'm talking about JSONs and streams, and the DB has to support some sort of fetching the data in chunks. And it's so think about it. If you, since we're working with JSONs, we can't really cut those chunks in the middle. You have to have a full JSON in order to do the transformation and things like that. So yeah, it supports this DB supports streams. We start implementing it by our own, but then we found a library that did it more efficiently. This is a good tip. Or don't try to invent the wheel. If there is a good library, don't hesitate to use it. So yes, this DB has some sort of this DB, we call it with HTTP, and it has an endpoint that supports fetching this data in chunks. So it's really important. I see another question: are streams similar with observables? Actually, observables use streams also. Here in this talk, I only talked about streams of in the context of data pipelines, but there's a concept that's called reactive programming. Probably heard of it. There's a famous library of RxJS and observable patterns. And observable patterns use streams also, but they use streams in order to communicate according to triggering of events. So it's really, really useful. And this pattern is very popular today, and use it also. But this is another use case of streams. Yeah, observable use streams also.
Cool. I have one more question. So
yeah,
can you use the streams just to read data from a database, or for example, if we have a form on a website and a user uploads a file, he's allowed to upload a file, and he uploads a 1 GB file. Can you retrieve that as a stream and not have to read everything like that 1 GB at once?
yeah. You can work with streams, and actually the request object and response object in Node.js are streams also. I'm not, I can't remember which one is readable and which one is writable, but they are streams also. So you can just work with those objects and stream them. And like if you want to do some sort of manipulation to it, you can pipe it to transform stream, Or if you just want to write it forward to some sort of source, you can connect the request that you have to a stream. Okay, I see another question. You had an example with generator within an iterator. What is the benefit of having an async generator inside an async iterator? Isn't it enough it have an async generator within an async iterator? Oh, yeah, I'm a bit confused. What is the benefit of having an async generator inside an async iterator? I don't really understand it, the question. Okay, yeah, give an example, it will be best.
You can also unmute yourself and talk.
Yeah, it will be great.
I know the feeling. I have my kids in the other room and they're like screaming and running. So that's why I'm muting myself from time to time.
Yeah, my kid is sleeping right now.
You lucky guy.
Yeah. Okay, in the meantime, you can take all other questions, okay? But let me talk about, so async iterators and async generators are basically, you can think of it as syntactic sugar, and they help simplify your code. First, the example of a readable stream with the syntax of streams, and you can work with this also. But I think async generators and async generators make things very easy and much less boilerplate and things like that. And it's much more intuitive to yield your results each time.
Okay, anyone has any other questions?
I will get back to mine. It will take some time until I do the code. Maybe I can ask Gadi to go back to the slides with the examples.
Yeah, sure. I have to be the host again. Can you please make me the host again?
Yeah.
Sure. All right.
Which is insane.
Let's see. You're talking about the async iterators and async generators?
Yeah.
Yeah.
Okay, so this is the generator, right?
Yeah.
Now you had an example where you had this generator, you had it within an iterator at some point. Didn't you?
With an iterator?
Yeah. No, that's okay. Please go back to the other slide. So what's the difference? So what's the benefit of using the await in the for loop? The parent wrapper function is already async.
Yeah. But think of it, I think this would explain more. This is just to demonstrate that you can combine those two. I'm not saying that you should do it every time, but it's just a proof of concept that you can combine async generators and async iterators together. But I think we can agree that for wait off loop is very, very nice, nice syntax. And again, it's syntactic sugar. You can think of it as syntactic sugar, and because you can walk with streams without the for weight of loop, right? Because you can pass those chunks in the stream. Maybe if you don't want to work with streams and just want to do something in this chunk, it's a useful thing. And also in the last example that I showed you here, I think it's really nice that you can iterate over this readable stream and doing the yielding of the data.
The yielding is okay. I was just wondering what are the benefits of the await, because it's syntactic sugar over the promise API basically.
Yeah.
And you already have a top level promise object with the async. That's what I'm wondering. That's what my question is basically. Would you have the same performance without the await?
We only for here without a wait?
Yeah.
I don't think you can do it. Let me see.
Or we cannot yield without an await. We can, right?
Wait, I have to see. Like if we're doing for. Yeah, I don't think you can do a for of streams.
Ah, okay. Okay, so that's the difference. Okay.
Yeah, because they are async iterator objects by definition. So you have to do the for weight of loop. Otherwise, you can't iterate over streams. They're not regular generators.
I see. And from your code, did you actually implement this in production? The async iterator?
No, I didn't implement it in my case because I have a pretty easy case, right? Because I just have three pipelines and I'm just piping them together. This is the code that I have in production, basically. I didn't use it, but as I read more and more about streams, I saw that the API keeps improving, and it's really nice in my opinion.
Oh, good.
All right.
Any other questions? I don't think so. So thank you very much, Gadi, for showing us the insights of streams. It was a pleasure to have you, and hope to see you again in other meetups. If you want to present again, just let me know.
Sure. Thank you so much for having me here. I had a really good time. Thank you all.
Thank you. Take care.
Thanks. Bye-bye.
Bye, everyone. Have a good day and stay safe.
Yeah. Bye-bye.
Thank you.
Bye-bye. Thank you, Gadi. Bye-bye.
Bye-bye.
Awesome. Can you make me host again?
Yeah, sure.
I'm not sure if I have to close it or you have to close it just to make sure the recording. It's gonna take a few days and then we're gonna post it. We have a colleague that he has to cut the beginning and just leave the presentation.
Okay.
Okay, thank you very much. And it was really nice. I missed some good old coding and not just like hands-on stuff somehow, because many meetups, you know, just talk about like concepts and stuff, but this was like, this is a solution for a problem.
Yeah, I
Really
try
good.
to show as much code as I can and do some demo.
Yeah, it's really useful.
Yeah, thanks.
You should actually, if you have time, and I think would be really good if you could do an article. I think would really be
Yeah,
good.
I
Or
want to
if
do
you
it,
have
but
one.
yeah, I want to do some sort of article about it, but it takes time.
Yeah, I know, but it's really nice, and it really fixes a problem that the users and many people have it, and you found the solution, and I think is really useful.
Yeah, I want to write more, but I just don't have time to it. I have to.
Yeah, I know the feeling.
So you know this problem.
Yeah.
Yeah.
Okay, so
Thank
thank
you very
you
much.
very much.
Bye bye.
Bye.